Hello, everyone. In this video, we are going to study the use of color in data visualization. In particular, we will talk about how to use color in data visualization, and we will understand color vision deficiency, and we will learn options for designing colorblind friendly data visualizations. So here is an example of a dashboard from the big book of dashboard. We can see that actually the good use of color here. It's very simple. There are only two colors, blue and gray. But the blue is used to highlight the data, particularly for those type of data below minimum wage. And it's been used consistently throughout all the colors in the throughout all the different charts here on this dashboard. Here is another example. So here you can see we have two charts. So if you look at these two charts, they actually convey completely different message. But only if you look carefully, the only differences between these two charts are the title, the color, and orientation of the bars. The second one is upside down, and they use different colors to convey totally different messages. So the sentiments are actually different by using different colors. So as we talked about this before, color is one of the most commonly used pre-attentive attributes, but however, it's oftentimes misused. So it's important to think about the purpose of color and how we are encoding our data sets by using color. So here on the left-hand side, we see some earth tone colors and the cool colors. So these colors are normally used to color code categorical data. The colors on the top right are unnatural colors. So these are colors that will draw a reader's attention. We can also see those colors that can alarm or alert the audience of your data visualization. So if you recall this chart, which we talked about from module 1, so there are different ways to use color in data visualization, primarily sequential, divergent, and categorical. So in addition, we can also use color to highlight or alert something to get users' attention. So here is an example of a sequential color on the map. So sequential color encodes a quantitative value from low to high. So the example here is the unemployment rate by state. It ranges from 2.6 to 7.7% using a sequential color scheme. So here is an example of using diverging color. So diverging color encodes a quantitative value but has a midpoint. So in this example, the midpoint is 0, and profit can have a range from negative 100K to positive 100K. Here the midpoint is 0, but many times the midpoint doesn't have to be 0. It can be the average. It can be other kind of a threshold we want to use. Categorical colors encode categories. So like different types of food, different types of apparels. So it can be very difficult to use a sequential color scheme for categories. So normally we use these categorical colors in this case. A highlight color is used to highlight one data point or category. For example, if you have 50 lines, each representing one state, then you might highlight one state with a particular highlight color. So this will allow the reader to quickly understand what you want to emphasize in your data visualization. So in this example, actually the slope graph is filtered to show 7 states, and with Washington, state of Washington being highlighted with blue color. Alerting or alarming colors are used to draw the reader's attention, similar to highlight color. But in this case, it's done with an alarming or alerting color to tell the reader that something is not right. So it's important to know that in Western culture, that red is often associated with bad things, but this may not be true in some other cultures. Like in China, red is always actually a good sign. So normally, bright alerting colors can be red, orange, or yellow. So remember in module 1, we talked about long-term memory versus short-term memory. So our long-term memory works very well for storing images of past experience that constantly references, but our short-term memory can only hold so much little information. So it's our working memory that it can be overloaded very quickly and easily. So that's why using too many different colors means that you will eventually run out of short-term memory, because we have too many colors to refer to in a very short amount of time. So we are going to quickly run out of storage. So because a user may refer back and forth to the legend to understand the meaning of each specific color. So that's why this is not a good example, and it has too many colors. Let's talk about color vision deficiency. So this is a picture, actually a comparison of what normal people with normal vision versus people with color vision deficiency can see of the red apple, green apple. For people with regular color vision, their eyes have 3 types of cones. So short, medium, and long. Each type of cones respond to different wavelengths. The medium cones are more sensitive to green colors, and the long cones are more sensitive to red colors. So in normal color vision, the eyes will have 3 types of cones, as we just mentioned. Each type of cones will be sensitive to different wavelengths. So when one cone is missing, the person will be blind or green blind, depending on if it's an L cone or median cone. If the person has 3 cones and has color vision deficiency, then they are either red weak or green weak, depending on the long cone or M cone, long or medium. Approximately 8% of men are colorblind, and less than 1% of women. Both the long and medium cones are coded to the X chromosome. That's why actually men has a higher percentage of color vision deficiency than women. So here you can see the 2-cone deuteronomia, which we call green blind, and the 3-cone deficiency, deuteronomally, green weak. So it shows you the band of what people with color deficiency will see. Actually, it will be difficult for them to differentiate this 2 to 3 different hues. Here is a comparison in the case of traffic light colors. So if there's no other accommodation for someone with the color vision deficiency, CVD, in this case, the colors red and green are the only way to tell one square apart from another square. So in the deuteranopia simulation on the right-hand side, you can see it's impossible to tell the difference between most of the green and the red squares. If we go back to the color wheel, which we mentioned before in module 1, we see the green, red are opposite each other. So what many data visualization designer will do is to turn on the color wheel clockwise to blue and orange. Blue for good instead of green, and orange for bad instead of red. The color combination could also be blue and red because it's the blue color that is the most friendly to people with CVD, color vision deficiency. Here is an example of bar chart with the traffic light colors and the protanopia simulation on the right-hand side. So look closely at the dark red versus the dark green. You can see how they would be viewed by people with protanopia symptom. Here's a close-up look at the previous chart with protanopia simulation. You can see it's impossible to tell the difference between the dark red and the dark green. So here is that same visualization using a colorblind friendly palette. Tableau has this colorblind friendly palette built into the software. And the colors used here are very similar to Tableau's colors with blue and orange. So notice how easy now to see even with color vision deficiency. The blue is easy to see even as the orange turns to a shade of brown. This visualization shows a great example of the Tableau colorblind friendly palette being used. So you can see there's a midpoint in terms of the percentage of the difference in rate, ranging from negative 50% to positive 50% with diverging color comparisons. Basically blue and red or orange color schemes for comparison. Here is another example. Here the timing showing survey data on the Likert chart scale chart. So here you can see the use of orange, gray, and blue colors to create excellent contrast between the colors, even for people with color vision deficiency. So keep in mind that it's not just the red and green that actually cause the trouble for people with CVD. For people in the data visualization community tend to discuss red and green more than actually other colors, probably because the traffic light colors are still prevalent in business intelligence and visualization software. So instead of saying don't use red and green, it would be more accurate to say do not use red, green, orange, and brown together. So in this example, there's no red, but the green, orange, and brown all appear to be the same color under CVD simulation. There are also some concerns with other colors. For example, this purple and fuchsia colors are problematic with the gray colors under CVD simulation. The blue is also difficult because it has gray hint to it, making it very close to the other colors. Here is a standard traffic light color palette and CVD simulation. If using the traffic light colors like this, be sure that the readers has some other accommodation to the data so that people with CVD will be able to read and understand the use of color in your visualization. So sometimes you may be forced into the traffic light color palette, even in situation when you cannot create an accommodation. So in this case, here are some color palettes that should help you design traffic light colors that can be useful. So for instance, you can see one thing you can do is leverage light in the dark colors. You can make the red very dark and the green very light, or vice versa. People with CVD can typically tell the difference between light and the dark colors by making the red a deep, dark red and the green on the lighter side. It's easy to see the contrast between these two colors. If you have the ability to change the colors even more, try adding some blue to the green color. This adds even further contrast between the colors. The executive or stakeholders can have their traffic light color, but you've accommodated people with CVD at the same time. This is a great example of a chart that wouldn't work well at all for people with CVD. Using traffic light colors, they might not be able to tell the difference in the bars. However, in this case, the last color scheme with a hint of blue has been used, and we can clearly see the differences now in the top bar and the bottom bar. And this chart from GraphGem, it's from graphgem.com. It's another reason why we hate pie chart. Because if the slices were red, green, orange, and brown, the chart might actually look very similar to this chart with just one single color. Okay, so that's all my discussion for the first part of this module about how to use color in data visualization. Let me know if you have any questions.